Hi folks, we're going to take a look at question 12 from page 103. So in this question here, they're asking us to find the symmetric equation of a line passing through the point -6, 4, 2, and it's perpendicular to these two given lines. Okay, so in order to find the equation of a line in symmetric, parametric, or vector form, we need a point on the line, okay, which is our R0, and we need a direction vector. Now we're given straight away that it passes through -6, 4, 2. So I have my point on the line. My goal here now is to calculate a direction vector. Okay. Now what they do tell us is that this line is perpendicular to both of these two lines. Okay. So say I've got these two lines, each having a direction vector. So the point I'm looking for, or the line I'm looking for, has to be perpendicular to both these lines. Okay? But if the line I'm looking for is perpendicular to the lines, it must also be perpendicular to the two direction vectors. Okay? And this is where hopefully we think, well, wait a minute. If I need a direction vector that's perpendicular to both of these two direction vectors, well, I've got something that'll take care of that for me, and that's the cross product. Okay, so in order to find the direction vector that I need, I'm going to take the cross product of the two direction vectors of the given lines. Okay, so let's take those here. Now remember that these are both given in symmetric form, so the direction vectors are given by those numbers in the denominator. So the direction vector for the first line would be -4, -6, 3. And the direction vector for the second line would be 3, 2, 4. Okay, so -4 and 3, I'll just set myself up to find the cross product, which will be the direction vector for the line I'm looking for. Okay, so here we've got -24 minus 6, so we've got -30. Okay, then here we've got 9 minus -16, so 9 plus 16, which is 25. And then here we've got -8 minus -18, in other words, -8 plus 18, so that's just equal to 10. Okay, and this vector here can act as a direction vector for the line I'm looking for. Hopefully, so you guys are starting to notice that, well, this is all divisible by 5, and it will be much easier to work with a direction vector that was reduced. So I do want you to get used to doing that here. So the direction vector I want you to use, okay, would be this one here divided by 5. So here, -6, 5, 2. Okay? You don't have to use this one, but it's certainly preferable. But now we've got a given point on the line, and we have a direction vector. We can go ahead and write the equation of the line. Okay, so I'm actually going to go ahead and write all three, just so that you can see how all three are written. So I can write it in vector form. So it would be the point, -6, 4, 2, okay, plus my parameter times the direction vector, -6, 5, 2. Okay, I can write this in parametric form, which is just the same thing with the individual parameters written separately. So here x would be equal to -6 minus 6t. Y would be 4 plus 5t. And z is just equal to 2 plus 2t. Okay, and lastly, we can put this in symmetric form. So it's x minus the x component of the point. In this case here, x minus -6, so x plus 6 over the x component of the direction vector, -6, equal to y minus the y component of my point, so y minus 4, divided by the y component of the direction vector, 5, and equal to z minus the z component of the point, in this case here 2, divided by the direction vector. The z component of my direction vector 2. Okay, so this is actually the answer they were looking for. Okay, that's it.